Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nohira binti Kamaluddin. My matrix number is 228158, and today I would like to present about understanding fluid properties and their impact on engineering system. Firstly, we will go through definition of fluid properties and then the rules in engineering, and lastly we will take a look at the challenges of managing fluid properties itself. So what are fluid properties? So fluid properties are actually characteristics that define how fluids behave in motion and at rest. So this is important to know because it is critical in designing pumps, pipelines, and reactors and many more. So in this presentation, I will walk through how viscosity, density, and surface tension affect engineering decision and outcomes. Let's start with viscosity. So viscosity describes a fluid's resistance to flow. You can think it of like honey flowing more slowly than water. That because it has a higher viscosity. So in pipelines, especially when transporting heavy fluids like crude oil, high viscosity means higher energy costs. Because it's harder to move, right? So engineers reduce viscosity by heating the fluid or mixing it with lighter components to make the flow easier and more efficient. If we don't consider viscosity properly, system may face high pressure losses or even equipment failure. Next is density. So density, the definition of density is mass per unit volume of a fluid. So it influences how fluids settle, rise, or interact in system. In water treatment plants, for example, clarifiers use density differences to separate solids from liquids. Also in pipelines or storage tanks, inaccurate assumption about density could lead to flow errors or worse, structural issue like tank lifting due to the buoyant forces. And that's why precise density measurements are essential for safety and performance. Lastly, we have surface tension. Surface tension is a cohesive force at the surface of a liquid. It affects how droplets form and break apart. This is important in systems like spray dryers used in pharmaceuticals or food processing. If the surface tension is too high or too low, droplets may not form properly, which affects drying efficiency and product quality. Engineers must account for this property when designing nozzles or choosing process conditions. Moving on to challenges. So one of the big challenge there is a trade-off in fluid behavior. So optimizing one fluid property often affects another. For example, if you heat up crude oil, it will lower the viscosity to have easier flow, but it also reduces surface tension that will affect droplet formation in spray system, and it also happen in compressible gas flow in pipelines where the pressure drops due to compressibility that make it harder to maintain constant flow, and this require compressor station and real gas models to predict behavior accurately. Another challenge is buoyancy in storage design. So for example, underground tanks may rise if surrounding fluid is less dense than the tank stuff. So engineers must account for this to prevent structural failure. So lastly, stability, efficiency, and safety is depending on you understanding how these properties interact. So we need to master these fluid properties for you to become a great engineer. So in conclusion, we need to master fluid properties to help us designing an energy efficient and reliable system, and to solve real-world challenges across oil, water, chemical, and manufacturing sectors. And also we as engineers, we need to anticipate performance changes due to pressure, temperature, or system demands. So when these principles are applied effectively, the safety the safety will improve and the cost of manufacture will drop, and obviously innovation will advance. That is all from me. Thank you.